education has changed with the world. The U.S. education system used to be number one. Today, it's 25th. To regain America's competitive edge, isn't it imperative that the way we engage their minds in play also engage their minds in learning? The National Flight Academy thinks so. Our goal? To transform the education system through aviation-inspired learning. To inspire, motivate, and teach students by tapping into their modern sense of adventure and passion for technology. The NFA programs are designed to reach into every corner of a student's world. At home on the web, in the classroom, in the community, all across the country. The National Flight Academy programs lead to extraordinary in-resident experiences aboard the Ambition, where students are immersed in multisensory media and simulation technologies to address real-time, real-world challenges using STEM knowledge.
You're flying 30 nautical miles east, 20 nautical miles north. Calculate bearing to target.
The CBR is 8 miles at 12 o'clock. Do you have a visual?
Applying the knowledge gained in the classroom, online activities, and regional competitions, students will win back America's competitive edge in science, technology, engineering, and math. The National Flight Academy, because there's nothing that an inspired mind can't accomplish.
So the video that you just watched was put together by the National Flight Academy to promote their program out in Pensacola, Florida. It's an interesting project that we got involved with about 2 years ago. National Flight Academy approached us and said, you know, we'd really like to kind of pull you in, your program in specifically, since you do games and you have instructors that have worked in the gaming industry. And we see a need to kind of take these interactive experiences in simulation and make them a little more engaging, add a little bit of game to them. And what they mean by that is fun. If you ever use a simulator and you hop in, you're in for a few hours of boredom. And so what we look toward to doing is taking some of the story content that the National Flight Academy was working on and infuse that in a simulator environment where there's some live action role playing aboard a building that's called the Ambition, and inside it, it looks like an aircraft carrier. It smells like an aircraft carrier. It was actually built by some of the guys that work at Universal Studios, and the story was written by one of the writers that actually was involved with working with the Imagineers, as well as Universal Studios writing story. At Full Sail, we had about 60 students that participated in building the content for this, within the simulator. From art students to our master's students in game design masters, they collaborated to build the content that made this thing a reality. And what was really great about it is that they actually had a chance to work with industry professionals, work with educators that were working on the curriculum to make sure that we were hitting core standards as we were doing this stuff. The aviation and residence stuff was not the only stuff that the students were working on, but also the classroom experience. So we would sit there working with the University of West Florida, and we'd do a back and forth. What did they want to hit for curriculum? How can we make that happen? How do we add some interesting aspects to these challenges that we care about related to the STEM field? Because ultimately, what we wanted to do was inspire you to do something along the naval aviation route. Right? We can hear a lot of stuff about all the things you can do, but there's a lot of people that go into making these things happen. So I think that's about what I have. A little bit about myself. I've worked in the game industry since the Super Nintendo days. Speed Racer, Independence Day. You might have heard of another game, Madden. Worked on that. Currently started a studio just around here doing mobile development for Zygobot, and we're building a mobile game, kind of puzzle platformer, and I think you can't escape the fun, but also the educational component that are in games. I think games can teach. Can we control what they teach, I think is really what we're trying to do. So that's what I got. Thank you very much.
We've structured this so we're going to have the several presentations and then some time for questions or comments at the end. So please hold your questions. The next group who's going to present in this panel is some students and a teacher from Timber Creek High School. Students are David Mitchell and Mackenzie Betteridge. They're here with their game and simulations design teacher, Phil Tillery, and they're going to talk to us about integrating biology and CTE through gaming simulation. Y'all can use those microphones or come up, as whichever you prefer.
Well, my co-partners here decided they wanted to sit. So we're going to keep it at that, all right? This represents about a year's worth of work. Normally a game would take a team of about 50 or more, quite some time to do. We did this whole work here with 4 students. And so along with Mrs. Stevens, our forensics instructor, this was put together. We have about approximately another year and a half to finish the project and its completion. Right now we just had the modeling set up and programming to follow. And I'm going to turn this over to my project manager, Mackenzie, over here.
Hello. I believe there's supposed to be a video playing.
Yes.
There we go. So we had the hopes of making a crime scene game. So it's kind of like any episode of CSI whatever, Miami. This is CSI Orlando. And we had to incorporate all of the ideas from the forensics class. The hope was to give it to the forensics class so that they could use it for, to assess their abilities, I guess. David was in charge of this whole map that you're seeing here, the entire layout, pretty much the shell.
Yeah, I modeled all of the buildings. I set up all the trees. The lake you can see in the center of it, you can't really see it too well at the moment. I had to sculpt that out, and just all the buildings set up. Now the area you're actually seeing though is actually more or less, it's Lake Eola, and all the buildings are where they should be. There was a few buildings I had to move just for simplicity's sake. Some of them were a bit too complicated to make, per se. But for the most part, that's literally a perfect model of Lake Eola.
You're seeing the dome right now, I believe that's what that is. One of the main complications was that we had to have 2 buildings across from each other so that you could help establish who the killer was in this CSI game. So David had built an apartment complex and another skyscraper right across the lake.
It was one of the, it's not showing it at the moment, but yes, there was 2 buildings. One of them was an apartment that we had to go inside, and actually we went into pretty good detail with the interior of the apartment. We, bookshelves, beds, everything. And actually right there you can see that was the apartment where the victim would have been in, and the shot would have been in the lower right area, the one that's kind of separate from the restroom. That would be the bedroom. And that was the killer's vantage point right there from one of the balconies on the left side of the image. That room in itself was supposed to be a renovated room to add to the, mystique of it.
So what you really need to understand for this is the storyline that goes along with this. We had 2 stockholders. One stockholder had hired a hitman to kill the other. And the hitman was the person inside of the construction area. So what we had to do was leave little pieces of forensic evidence all over the construction area. The way to get to the construction area was fairly difficult in itself. You had to reconstruct shattered glass because the whole side of the apartment building was glass. And then you had to use this laser pointer that we built that would trace the trajectory for you so that you could go back to the construction building. Once you got to the construction building, you would find small little pieces, like we left a hair on a wall. It was that small. There was a second body there, which made it a whole lot more complicated if you were playing this game. and there was a fiber on the second body's outfit. That's a microscope, obviously, right there. I'm hoping most of you know what a microscope looks like. The microscope and many other small little forensic pieces were made to determine the hair. So there's very detailed little points that you need to know about forensics. So all of the forensics equipment we built microscopes to Bunsen burners to a brush to dust for fingerprints. I don't know. Oh, that's a vehicle.
That doesn't quite look like a medical instrument, we know.
Yeah, I guess the materials were never quite finished there on those vehicles.
But they are very nice looking, you gotta admit that much.
Well, let's see.
Anyway, so what she's basically saying was that this entire game was it's very detailed. There's a lot of details that we looked at and put into the game, such as all the equipment. We fully modeled it out. Unfortunately, at this time, we didn't actually get to finish a lot of the actual programming bits of it. However, we planned to put that in, just never got around to it, I guess.
So what you could say is the entire project is constructed, but it's not functional.
Yes. We have all the pieces together, just not the game board, you could say.
Unfortunately, we ran out of time. The end of the school, they didn't want to come in over the summer. I couldn't understand why. Sit there and complete this.
Yes, he couldn't understand why we didn't want to come to summer school.
So some more of the small little details. There were days where I would actually just go to the forensics classroom, grab a bunch of forensics equipment, go back to the simulation classroom, take some pictures, and then start modeling those. So I would be carrying like bottles of acid across the school. It was interesting, but some of the detail we went into. We actually created fake emails so that you could find documentation of the evidence on both computers, on the hitman's computer and on the victim number one's computer. So for several days, we were just emailing each other back and forth. That was interesting also.
It doesn't sound productive, but trust me, it was.
Most of the time.
Most of the time.
The construction site, the entire interior was building where the hitman was. You had to build like a normal construction site, which not a construction worker. So that involved a bit of research. The apartment, the previous year, I had extra time and I built a house. So thankfully I had saved that house. And what we did was we took a lot of the interior of my house that I had built and we put it into the apartment. So we had a refrigerator and we had counters and we had chairs and we had some couches. But then we had to build bathrooms, we had to build a bedroom, and we had to build a desk because we have the emails, so you need a computer. You got anything?
I just think it's funny just watching you fluster about. I'm sorry. To be honest, I shouldn't be talking. I don't have anything in my head either. So,
one final piece there. We had anticipated at the end of this is to go through, and we have a law class at the high school and so forth, and to actually go through and collect all the evidence. And if you weren't close in collecting everything, you might convict the wrong person. So we would run it through at the end is what the anticipation of. To run it through and it says, oh, congratulations, you just convicted the wrong person. You may want to start again. All right? Because what we want to do is go through and make sure that they grab everything that they should be, and this is more indicative of real life. Okay?
We plan to actually have a whole database of all of the materials you collected. So if you got something wrong, like fingerprinting, for example, we had a database of up to 7 people's fingerprints. And when you're tracing fingerprints, you have to find these small, tiny little points. So it's kind of easy to mess that up. So we would have a whole separate side thing in case you wanted to look back and make sure you got it right.
Well, I hope you enjoy.
If you haven't done it, that's a hint of the kind of deep background work and team effort that goes into building any kind of game or simulation. It's a little easier when you're working with a company with 100 engineers. Our next presentation is a group from Lyman High School, students Jason Parmalee, Juliana Abudi, and Kyle Sellers, who are here with computer modeling and simulation teacher Lynn Higgins, and they're going to talk to you about rigging animation and gaming or motion capture.
I want to thank everybody for allowing us to come out. And what we're going to do today is we're actually going to take a brief synopsis of the current curriculum at Lyman High School. Basically, we're going to start out with Kyle here, and he's actually going to go over 2D gaming systems using Flash. We're also going to have Jason. He's going to go over Cinema 4D a little bit. He's going to go over actually rigging an avatar and actually generating walk cycles. And then Juliana is actually going to go into Adobe Premiere. We actually use Adobe Premiere as basically our compile engine, and she's going to go ahead and compile a animated short. And right after that, she's going to actually display her junior animation that she did last year. Every single one of these students up here, this is basically a 3-year curriculum, and each year they get very heavy into coding. So they do a lot of coding. They also get into image processing, and they also know all the modeling, the rigging, and so forth. And so Juliana's sort of going to finish that up with her animation that she's got to do, and at the very end, basically, we're going to be getting into 3D simulations using Unity. We've used other game engines in the past, but they seem to be a little more complex. Some of them are actually very heavy into C++. Some of you might actually know that. Basically, that's Ogre. There's no front end to it or IDE, but it's solid C++. But what I like about Unity is that it's pretty much synonymous to the same engine that's in Flash. So basically, in Flash, they use what's called ActionScript. But it's synonymous to what's called JavaScript, and actually Unity uses JavaScript. So basically the transition from a 2D system to a 3D gaming system is actually very much simpler. So with that stated, I'm going to go ahead and start out and let Kyle have the floor, and hopefully I know we got a PowerPoint here with some videos. Hopefully it'll come up soon.
All right, thanks, Mr. Higgins. All right, what you're looking at right now is the setting up of an array, the blocks on a screen for a kind of complicated game that we made. And as it scrolls through, you can see the different parts of the array. Down there at the bottom, kind of coming up to the middle, is actually the disassembling of that array when you want to reset the game. Right there is the paddle movement. So you have these little paddles that'll deflect the balls, and that's the setting of those paddles, and that is the movement of the paddle scrolling by there. That's the turret movement kind of scrolling by. It's we use some advanced trigonometry to figure out the velocity of the balls that are going to be launching out of these turrets, and we have to figure out the angles at which the turrets must also be properly pointed. I can't read that. I believe that right there at the bottom of the screen is the attachment of some sounds so that when you win or lose, or when certain balls are launched from the paddles, you make sure you have audio in your game and it sounds right. And then it's also the detachment of those sounds. I think that's the end of the slide. There you go. This is Flash right here, and as you can see where the mouse is, those are layers, and you can move those layers up and down, determining where things kind of hide behind each other and how you want things to look. If you can see it, there's a little eye in those dots below the eye. When you click on those, you make that little red X, and you can make that entire layer disappear so that you don't have to see it when you're messing with other things. And that lock also makes it so you can't interact with those. Here we have independent movie clips so that we can make these independent objects and put them into the overall game. You can make little simple animations like that to make the ball seem like it's actually flying through the air as it moves. There you go. There's the paddle kind of exploding when you lose. All right. This is the actual game that was made from that file. It's called Battle Ball. Here we have a little simple animation just to kind of make the title screen a little bit more interesting. All right. If we go ahead and play the game, you can see all those blocks in the middle. That was made from the array I was talking about earlier. And each one of those blocks has to be able to interact with the balls that are launched from that the turret that we had to use the trig to determine the velocity of and angle of the balls. There you go. You have paddle at the bottom there, launching a little bit of those missile things. You can see a little bit of hit detection as things bounce off the paddle and the arrays. There you go, the paddle launches and explodes. All right, Juliana's going to talk about, Jason's going to talk about it.
All right, this video is in Cinema 4D, a 3D modeling system that we use. And this is a process for rigging the avatar that you see on the screen there so that he can have realistic movements and basically leading to the goal of setting up a walk cycle. Here, you're just basically setting up joints that match the bone structure of an actual person so that in the long run we can set up controllers to them and be able to control it with realistic motions. There, I'm just connecting them all to the main, the spine of him so that it all connects together. And finally, you have to bind that skeleton to the mesh of the avatar that you're using so that it moves along with the skeleton. Now this video is me setting up the walk cycle for the same character that you just saw. I start by moving the left leg back, setting up the walk cycle, and at the bottom of the screen there, you can set a keyframe for your animation. So at one frame, when you have it in one position, if you move 10 frames and move it to another position and keyframe that, then it actually sets the motion that you just put in. There, I'm scrubbing through the animation to make sure that it looks good. And then I do the same thing with the right leg, which will be coming up, making it look like a fluid walk cycle, somebody actually walking. On the right-hand side of the screen, at the top right is the object manager, where all of your objects are that are placed on the screen, all of your meshes, your controllers, the actual joints that we set up in the previous video. And there, I believe I'm finishing up his left or his right leg. And then I scrub through to make sure that it looks like he's walking correctly. And next, I set up the back so that it's not just a static motion of his legs moving, but it actually looks fluid and more realistic by moving his back down with each step. Just wanted to make sure it was working there. And finally, I set up the arm sway so that you actually looks realistic and not just his arms stuck down to his side. And finally, I scrub through it one last time, and then I actually play the walk cycle I set up. Next, we have Juliana, who will be presenting Adobe Premiere.
Thank you. All right, in my video, I'm putting together an animation I made in Cinema 4D. And right now, all you'll see me doing is importing my rendered stills that I rendered in C4D. This is my junior animation that I made last year. Right now, I'm just uploading my Scene 1 and Scene 2. And they're just dropped into the little object manager on the side. Now I need to just drop them into the timeline, the video timeline. Now I'm scrubbing through just to make sure it fits. Now I have to resize it because the size wasn't correct, so I need to see it in the little corner. All right, now I'm just scrubbing through to make sure it's playing correctly. I don't think you can see it very well. But now I'm just getting the audio. That one, I think, is the gate opening. There is a gate right there. It's creaking open. You'll see it in a later video. It was too small. I just have to speed it up a bit. Now I'm just getting the walk cycle, drop it into the timeline, and just to test. All right, now this is my actual animation that I made last year. That's what I was working on in Adobe Premiere. It should be playing shortly. There you go. It's called The Cake. There should be audio, but I don't hear it playing. Basically, all the audio is just you'll hear the walk cycle, the person. It's actually a person, first person view, and right there is a cake. You would be hearing a barrel being thrown across the screen and slamming into a wall. That's what that is right there. The cake was replaced by a scythe left by death, and their death is using the walk cycle that Jason just went over. And that is the end of my community animation.
Okay, what we're going to address right now is we're actually going to take a look at 3D simulations a little bit. We actually use Unity this year. This is our first year actually using Unity itself, and we'll be getting into this actually in January. Due in January also, they each have a senior animation, which has to be twice as long from the one last year, which is 30 minutes. But the other thing I'd just like to sort of emphasize here is that all these systems you're seeing up here basically were developed by the students, and each thing that you're actually seeing was not specific to each student. In other words, basically every single person sitting up here, they've had to develop every single one of those games in Flash. Basically, Battle Ball, which Kyle was going through, that's actually the most intensive. There's a lot of trig involved in that, a lot of event handlers and so forth. All the rigging, the animation that's been presented, everybody has to do that. It's not just one person. But with that saying, basically we're taking a look at Unity right now, and basically the front end is very similar to that of the other systems we've seen. Basically Flash, we've also seen Cinema 4D. They have object managers. Same thing actually happens. What we're doing right now is we're actually importing the walk cycles that actually Jason developed. So we're importing that, and what we're going to do is actually place that on the screen, and we're going to go ahead and basically scrub through it once, and we'll actually hit play and see exactly the walk cycles. What we're actually looking at right now is basically the game view. This is actually a first-person view also, but actually moving around actually in Unity is much more convoluted than actually moving in Cinema 4D or basically Flash itself. Now what we're actually taking a look at, basically all these objects that you see out here, nothing was actually developed in Unity. We use Unity basically as is, as a game engine, that's it. Everything was developed in Cinema 4D. In order to actually get all this stuff to work, we've got to write code. These are called event handlers. Basically, there's 3 different types of event systems, but Unity uses what's called events and basically callback structure. What we're taking a look at, every single object, if it's going to have collisions, it has to have rigid bodies, has to have rigid body dynamics on it, it has to have the colliders on it. In order to physically get them to react, they've got to have handlers or sections of code that actually determine whether another body collides with it, what to do when basically a body collides with it, the impact of it. Based on the impact, we should be hearing some crashes and so forth. So that's what we're taking a look at right now. One of the things that I'm highlighting at that point, basically, once you have your avatar built up, you have anywhere at a minimum maybe 4 different walk cycles. This one actually has 5 different walk cycles, and what we have to do is we actually place this in an animation controller. What the animation controller does, it basically allows you to go ahead and transition from one animation cycle to the next. And so that's actually how we get the fluid movement of rotating left and right, which is what we're going to see here in a second. And I'm not sure exactly where we are. Okay, what we're taking a look at on the right-hand side, basically it's like what we've seen in Cinema 4D. That's the object manager. It contains all the objects for everything that we have. Basically the same thing as the project manager. The thing on the top basically is known as the animation controller. Now what we're going to do is we're going to throw a physical object here. This object that we throw, actually, basically there's event handlers that are running on our avatar that we built. Actually, that Jason went out there and built the walk cycles for. Every single object on that screen has event handlers that are running. It has colliders with it. It has rigid body dynamics in order to get it to physically react. There's also audio in it also, but I guess we're having problems with that, but that's fine. So there's a lot actually involved in this. When you develop basically a simulation system, any type of gaming system, it's not throwing stuff together. Now, a lot of times every single year, I get a few students, I'd say probably good 50% of students come in and they want to say, I'm going to build a game in 2 weeks. It does not take 2 weeks. There's a lot involved. There's a lot of computer science that's involved. There's a lot of coding. Every single year, these students go through tons of code. What they also address, basically, they address image processing. Now, like I said, this is just a general synopsis of the stuff we cover. It's not everything. But they have a good idea, basically, the animation cycle that has to be obtained and also the simulation cycle. But with that, I guess I'm done.
If you think about that briefly, for the purpose of a game, they want it to look right. The difference between that and a simulation for the purpose of training would be making sure that, for example, if those blocks falling are an important piece of equipment in your training program, that they actually behave like the real thing. So the game aspects and the training aspects are closely coupled, slightly different. The final speaker for our panel, this first panel this morning, is Darren Hughes from the Synthetic Reality Lab at the Institute for Simulation and Training here at UCF. And Darren is going to speak on STEM video games and interactive experiences. Thank you.
Thank you. Yeah. I guess I'll stay seated here because I have far less of a chance of falling over. Okay, so, wait, first of all, I'm curious, how many of you guys in here play Minecraft? All right. Anyone here lucky enough to be going to Minecon by any chance? Yeah? Talk to me after this. Hook me up. Okay, if we could bring my slides, I'll stop messing around. Okay, so I design games, educational games. I have a fantastic job. It's wonderful. I get to be creative all I want. I get to come up with all kinds of wacky ideas and then act upon them. So I've created a number of educational games that were specifically targeted for STEM, but I wanted to talk about something a little different today. And this is an educational game, but of a different kind. And one of the things that we thought was maybe we could make a game that would help teach empathy or perspective taking. And I started doing some work with some folks over in the College of Education, specifically Trey Vasquez, through a Teaching Academy Faculty Fellowship. Well, this has now turned into where he's actually my advisor in my PhD right now. So it's been a really nice collaboration. If we could go to the next slide. So, yeah, I have a fun job. So one of the what we're looking at here is games. Naturally, when you're playing a game, you're taking on another perspective. There's a natural form of perspective taking that goes on. And in order for me to be able to empathize or be able to understand someone, I have to be able to see through their eyes or walk in their shoes, as they say. We do this when we play video games, whether we're in Minecraft and what's the character, Steve or whatever, the Steve character, yeah. And we're seeing through those eyes or through the eyes of a soldier or whatever it may be, we're taking on another perspective. So we thought maybe we could use that in a way to create a game that would train perspective taking and possibly empathy. Go to the next slide, please. So this is the slide because the numbers on autism spectrum disorder have been increasing at a wild rate. You can't just say it's because of expanded definitions or because of better diagnosis. It's happening. It's accelerating. We're seeing a lot more of it. So it's a problem that we need to address. Next slide, please. So why games? Well, for one, this gaming and simulation in general provides a very safe environment for us to experiment, to play around. We can act out on certain things and see what the consequences are without having real life consequences where we might say something inappropriate or be embarrassed or do something that might be harmful. Next slide. I have too many slides, so I got to move through them fast. Oh, hi. Okay, so I talked a little bit about this already, but one of the things with autism spectrum disorder is what we've seen across it, and this is a generalization, but is that typically they have a difficult time with perspective taking, with empathy, with being able to understand another person's perspective on an issue. This is not to say that if you meet someone who has autism spectrum disorder that they're going to be that way. There are plenty of examples of people out there who have lots of empathy. But as a generalization, this is a common characteristic that we see in autism spectrum disorder. The good news is that that early intervention can be very effective, and we can do this through modeling, prompting, and reinforcement. This is done in traditional behavioral therapy, but what we're looking at is taking some of those aspects and moving it into a game, because not everybody can have access to behavioral therapists or have the money to be able to afford it or be able to do it with a kind of regularity. So we're looking at a game that would be free that people could play. Next slide. So we have the Wubbies. And what we want to do is create a character, an avatar that was neither cat nor dog in case someone's had a bad experience with a cat or a dog biting them before, and neither male nor female, but could have some of the same types of wants and needs that a child or any kind of human might have. Next slide. So, yeah, it's fun. So here we have, this is an example of a Wubbie. And the idea was to make something that could run on all kinds of platforms. We wanted to use HTML5 right now because it's very open, and we can make one game that works, this is the theory anyway, one game that will work on all devices. If it has a web browser, it should work on it. Next. So another thing we wanted to look at was giving the kids the ability to create their own character, because what we want to maybe see is if there's some characteristics that are preferred, some trends that we can find over time. Maybe they like larger eyes or smaller eyes, bigger ears. So that was something that we want to look at, and then maybe be able to pull some generalizations from that. Next slide, please. So in terms of environments, we were creating basically a household environment, the types of rooms that you might have at your home, where you'd have certain types of interactions that you have to go through every single day, whether it be going to the bathroom, eating food, playing outside in the backyard, sleeping at night. Next slide. And then in addition to that, we have mini games that are sort of meant to reinforce the empathetic responses, which I'll get to in a second what those are, but basically taking care of the Wubbie. Next slide. So we have a number of emotional indicators too. So how do you know if the Wubbie's upset, right? Well, you can see he's pretty upset in that bottom one there, he, she. And so what we have is we have multiple indicators here. So if you guys have played Sims before, maybe you're familiar with kind of this metaphor. But we've got, we've got potty, we've got a sandwich, we've got a drink, we got, I can't even see my own slide right now. Well, anyway, all of those line up to different types of needs that the Wubbie has. And so we have indicators that go from green to red, but in addition to that, we also have facial expressions. So if you don't take care of the Wubbie will get upset. If you don't take the Wubbie to the bathroom, he will pee the floor or pee the bed. He will. And he'll get upset, and he'll probably cry at some point. And then, of course, there's the sounds, too. So we have multiple methods that the Wubbie is communicating to you that I need you to take care of me. And when you do take care of him, he's very happy. And then it unlocks games and awards that you can have. Next slide. So, on that topic, we have achievements, and these are just further incentives for taking care of the Wubbie. Interestingly, I've piloted this with a number of kids, probably over 100. Not really the demographic that I'm looking for, but around 9th grade. I'm looking, obviously, for much younger than that. But what I found is that girls absolutely loved playing this game. I mean, the guys did too, but the guys were in it to break them. They wanted to break the Wubbie. They did. Well, what can we do? Where can we trap them? Where all the girls, they wanted to figure it out, how to take care of the Wubbie and make sure the Wubbie was happy. So it was very interesting. It was pretty much across the board, right down the middle, gender split. I mean, that seems to ring true, I see, for everyone here. Next slide. Okay, a little bit more on the geeky end of things, but this is a very important part of it. We want to be able to understand if this game works. So a big part of it is the back-end data collection. So every time you interact with this game, and it's done on a touch surface, it can also be done with the mouse, but every time you interact, we have all these different variables that we're storing and recording. Right, so we know exactly when a certain interaction occurred. We know what facial expression the Wubbie was making. We know where the meters were at. We know if the Wubbie's peed himself or whatever. We know all those things. We know when they happened, and we know what the user did about it. And this allows us to be able to create, research around something like this, as opposed to just saying, well, this seems like it might work. We could actually, when we're done with this, be able to say definitively whether it does or whether it doesn't, and what parts of it worked best and what parts of it didn't. And that's, what part of what being a researcher is all about. Next slide. And okay, so just a couple other things. We're in formative evaluation. We've got studies planned with children with autism coming up next couple of months. I was hoping to graduate this semester. It's not happening. And then I'm working with Trey Vasquez, Matt Marino, Rob Lindgren, and Peter Kincaid. And as you can see, I guess it was at one point in time a little more diverse of a committee because Rob Lindgren was here at Digital Media, but now he's a College of Education folk. But this is a really nice and almost unique situation. I'm a modeling and simulation PhD student, and as far as I'm aware of, I was the first one to have a College of Education professor be the head of my committee. And hopefully we'll see a lot more of that type of collaboration in the future. Well, thank you very much for your time.
The themes you're hearing today are video games, serious games, and simulation, and you can see the interplay among those possibilities. We have a few minutes at the end of this panel for questions.
I have a question about the Wubbies. I think that's what they're called.
Yep, you got it, Wubbies.
All right. Now, for each child, is it only one Wubbie that they're exposed to?
Yes, that's correct. It's not really a multiplayer game, so it's an individual Wubbie. Now, ultimately, we want them to be able to customize that Wubbie and create it the way they want it to be. Mm-hmm.
Do you think that level of possessiveness and identification with only one Wubbie will limit their ability to show compassion for a range of other organisms and people?
Well, that's a very good question, and I think that's partly why we didn't use, a human character. We used something that's sort of a fantasy type character, such that maybe that can, it can translate to a wide variety of creatures. But also, we want them to be able to understand themselves because that's a problem as well. So, knowing maybe a little bit more about, their own body by coming to understand, putting them in the position of the caregiver, as opposed to the person being taken care of. But that's a good question, and I mean that's the type of question that we would want to look at and investigate.
Okay.
Hi, yes. I was wondering, for a question of the Wubbies game, it said it's similar to Minecraft, correct? In a way,
it's more. I would say it's more similar to a game like Sims.
Okay, well, that's what I was about to ask you. How do you think this does a better job of, investigating the emotional connection, empathy, compared to a game like Sims where you have a lot of similar characteristics when you're playing it?
Sure.
What do you think advantages this game gives you over something similar like Sims itself?
Right. Well, for one, Sims wasn't designed for that purpose, where this game was, and this Sims is a very complex game. I don't know if you spent much time playing it, but I mean it's definitely intended for teenage and up. We're looking at a much younger population here, so. This game, the interface is designed to be very simple, intuitive, straightforward. There's really no text involved in it. Where in The Sims you can get involved in all kinds of stuff, complex relationship things and perhaps stuff that's not entirely appropriate or even, necessary to think about at that stage in their life. So this is designed specifically for that population where Sims may have that kind of effect. It may, but it wasn't designed to do that, and I don't know that they're looking at researching that as a possibility. Maybe they are.
Darren, can I follow up on that? This game collects data on the users.
That's correct. Yes.
This game spies on you, right? That's the purpose. But I think Sims probably doesn't. There was a question. Question up front.
My question is for the high school groups. I'm just curious to know your graduates as they proceed and go to college or select different colleges and different programs. Where do they typically go, and what does this curriculum help them to do in their careers after high school?
You speak.
Right now, I have probably, I'd say, a good 30% actually major in computer science, computer engineering, something along those tracks. I have actually quite a few of my students actually go to UCF. One of them actually currently works out of Institute for Simulation Training. So they've actually done fairly well. Most of them stay in basically, like I said, for a computer science engineering track. But I've had a few that get all the way to the very end and decide that they want to be a doctor. So they want to go into medicine or some field like that, and they've done some really awesome stuff. But what I always do is I encourage them to do something they enjoy. I mean, because they might be doing this for the next 40 years, and if they're not happy with it, and even though if they do a great job, I want them to be happy with what field they elect.
Also, with my students and so forth like this, she's defected. She's going to be going into forensics as a result. So I think that's great.
Do you have any more future projects in mind for educational games?
Yeah, one of the things that if you all will see later on today, some other folks from my lab, they're going to show you a simulation called Teach Live, which involves digital puppetry. The purpose of that one is actually for pre-service teacher training. But we do a lot of digital puppetry in our lab. But this is where you have a human actor, or what we call interactor, who puppeteers the digital characters, which gives a life to them that AI could never possibly bring. So one of the things that we are looking at is taking the idea of the Wubbie and then turning it into a puppet that can be puppeteered. Figure if the kids have already grown to have some kind of relationship with the AI Wubbie, they may be more inclined to have conversation with a Wubbie that's being puppeteered. So yeah, we do have there's lots of future plans all the time. Yeah.
Would you consider adding to the game after a certain amount of time? Like say the child could unlock a friend for their Wubbie, so they could, after they each to their own, get to see variety in how emotions are expressed?
Certainly. Do you mean making it sort of multiplayer by unlocking a friend? Do you mean a secondary character in the game?
Possibly.
Yeah, I mean, I think that's a part of if we see that we have success with the way that it is right now, then building from there becomes a possibility. I think right now, just want to figure out if what we're doing right and what we're doing wrong, and if we find that another character would benefit, then we certainly would go ahead and do that.
Can I ask you all to please thank the members of this panel?